Imagine you're in a large, empty hall and you shout something. What happens? Your voice echoes back because there's nothing to absorb the sound. Now picture the same scenario, but with curtains and carpets in the room. This time your voice is clear, and there are no echoes. This is exactly what happens in Profibus communication when you don't use terminating resistors. Except instead of echoes, you get signal reflections that can mess up communication between devices. Now think of this Profibus cable like a long hallway. When a signal is sent down the cable, it travels from one end to the other. If the cable is not properly terminated at both ends, the signal will hit the end of the cable and bounce back, just like an echo in a hall. These bounced signals, called reflections, interfere with new signals being sent, leading to data errors, miscommunication, or even complete failures in communication. This is where terminating resistors come into play. These resistors act like the curtains and carpets in our earlier example. They absorb the excess signals, stopping them from bouncing back and forth in the cable. Why 120 ohms? The answer is simple. It matches the impedance of the cable. Every cable has a certain characteristic impedance, which is basically its resistance to signal flow. Profibus cables have an impedance of around 120 ohms, and for termination to work effectively, the resistor value should match that impedance. If you use the wrong resistor value or no resistor at all, you risk communication failures, data corruption, or unstable network behavior. Skipping termination in a Profibus system can cause unstable communication, increased noise, and device failures. If you want your Profibus network to run smoothly, reliably, and efficiently, always ensure that both ends of the bus have proper 120 ohm terminating resistors.